Right, here we are in part 4 of the Tagger tutorial. This is part 4.2 because this is really we're going to be talking about the query language some more. So in last part we kind of scratched the surface. We kind of covered the basics on the query language, what it can do. Now we're going to get into kind of the meat of it. We're going to be talking about probably a couple of different things at once. So we're talking about um, subtags. So that has to do with the query language, but it also has to do with tagging an image with subtags. So we'll talk about subtagging an image, which is pretty useful. We'll talk about doing multiple set combinations in a single query. Open my database again. Because before, how I showed you to do that is, you use this drop down here, but you can also do multiple set combinations in a single query. So we'll just go ahead and do that now. So let me see if I can just on the fly, can construct a query. So let's just say that we want to find, maybe I'll use one that I've talked about in chat before. So we want to find every character, which I think we can just use this char percent, right? That is hugging another character, hugging another character, like that. All right, and so here we see something new. Okay, so we have these kind of curly braces here, and if you were a very perceptive watcher in the early sections or in the early parts of the videos, you would notice that the tags up here had their subtags grouped inside curly braces, and so that's exactly what we're doing in here. Is we are querying with subtags, right? So we know that since this doesn't have a dot token appearing before it, that we are trying to search for this meta descriptor character. So we want to find any of these descriptors that is subtagged by this hug, which is also a meta descriptor, or it could be, it doesn't matter, is some descriptor, and that's also relation search. So we can just type r dot just to make that explicit if we want. So any character that is subtagged by any hug that is subtagged by any character, and we can also just call it r dot. It doesn't matter if we do or not, and we can search that, right? So we'll go ahead and search that. I think there's only one that I have. There's two, right? So we have this one. So, and we can in fact see that the query results for this are what we expected. So we have both of these characters. We have Sachiko and we've got Yui, right? Both cuties. One's cuter than the other, but we've got one character. We've got and here I'll just pull up the history so we can see that search again. A character Yui, subtagged by a tag hug, which is subtagged by a tag of a character, which is Sachiko, right? And then we can go in here. So let's see. Yui is a passionate character, right? And then Sachiko here is a cute character. So they're both characters. We can see that. And so that's what that query was, is that they're both infra to character, and they have these subtags. Atsuki Yui has a hug subtagged by Koshimizu Sachiko, right? And so that's kind of a simple way to do queries. We could also do that the same way. We could get this exact same result, and we'll go ahead. We'll see this other picture just because it's also got Yui in it, so it's just inherently cute, right? We can achieve the same result, at least for this picture, if we wanted to, or maybe it's a better example if we mix and match. So say that I only wanted to see any images where Yui is hugging somebody, right? So we can do this, like that. That'll bring up these same two images. Oh, no, it didn't. Never mind. That's because actually in the other one, now that I think about it, let's see. So, yeah, see, so it's subtagged with hold. And the only one doing any hugging in this one is Rika, which I don't necessarily know if I agree with that. I might have to change that. But we can see actually, let me see if I can find that tag. this is something I'm kind of meaning to add in as a search function, because once you get these kind of big nests here, it's kind of hard. Here, hold. So hold is a meta tag and it has hug inside of it. I have this held by tag. I don't think it's used by anything, right? But we can actually, if we go back and redo this query here, we'll go ahead and change this to hold like that, and that'll bring both of the images up again, which it did. Okay. So that is how we query on subtags. So as you saw with our previous example, it works. You can mix and match both distinct descriptor searches with relation pattern searches, and it works just fine, right? One thing that you could do also is you can do pattern searches with it, right? So if I wanted to find, and we'll do this exact same search again in a different way, if I wanted to find every image that was in the Idolmaster Cinderella Girls folder. Don't forget the wildcards. You can do this, excuse me, you can do this pattern match here with a file, and then you can also do the same thing again, hold, like that. And it brings up both of those again, right? So we see that that it searches for all the files that have that pattern, and then all the files that have tags that are subtagged by these tags, right? So it's kind of a complex query, but it's really pretty elegant, if I do say so myself, in the query language. We could also do, if we wanted to, and this will give us the exact same result. Again, I'll just show you how to do 500 different queries that all have the same result. These should give us the same thing. Oh, it doesn't. Okay, well, hold on. So let's see, what is it trying to do here? So this is some more live debugging here. Okay, so I got to figure out what this is doing. So this is searching for any file that has this Cinderella, that has this tag hold, that is attached to any of these Cinderella. Okay, so this is a little bit of a peek into how the actual query language engine works, right? So this file pattern isn't an actual tag, so when we do a subtag search on it, it doesn't know actually that we want to search for subtags, so it just searches for the tag hold. So I'll clear this, and we can run this, and this will bring up these same files, and basically all it's doing, you know, this might be an image that we talk about later, just because given of how complicated these tags look, right? It might be kind of useful to talk about. Plus, I'm kind of partial to it myself because of a certain character appearing in it. But every single one of these images that are appearing in this query all have some subset of hold in them. Like we have hug in this one, we've got hug in that one, we've got a hug in that one, we've got a hold in here, right? And that's just because of how this works. And so I'll talk about that when we get to our set operations, you know, in a couple minutes. So we've got our p-dot queries here, and you know, kind of like how that last query worked, as you can see, is it works the other way around if you have this relation query nested with a pattern query. So I kind of would expect that this would work the same way. I don't know, maybe I'm exposing myself for not knowing exactly how the program that I wrote works, right? Okay, so it does. It works the exact same way. Here's another one. Right. So both this hold and then p.cinderella and then p.cinderella and hold both work the exact same way. And so I'll talk about that in a second. That's, you know, it may be helpful to know on the front end, but that's how those pattern queries work when you do subtag searches, right? With the curly braces, that's called a subquery. With the curly braces, you run a subquery. And so earlier on this first example here, you know, we just had these subqueries here. Is the r.hug subqueried with this car, you know, doesn't matter all that much. and then we can have, let's see, if you do like a D dot and an R dot search, it works the way that you would expect it to, like I talked about before. We can do let's see, a P dot, Cinderella, and then we can just do a U dot A, and this should pull up all of the untagged files that have the word Cinderella appearing in their file path, of which there are at least 101. Some of them are UE pictures. So, and note that this one has tags. The reason that it's appearing in here is because it was unioned with the results of the previous query, right? So that's where the set ops come in. So we'll talk about those now, because we've talked about the untagged options, or I mean not the untagged options, but the subquery options here. So we'll start talking about unions, right? And so when you make a query, so we'll query, since we have Jogasaki Rika in frame here, we'll drag her down there, and we can search for anything that's tagged with her. So we have got all of these in here. Got all these images with her appearing somewhere in them, right? And then, so we have all of those files currently in this selection. So say that we want to find all of the files that have both Rika and her older sister, Mika, appearing in them. What we want to do is run a union, right? And so since that's currently selected in this dropdown, that's perfectly fine. So that the fact that this is in this dropdown tells us that any query we run in this bar here is going to be unioned with the results of the files that are in here, right? So we want to find all the files that have Rika and Mika in them, so we want to union them all together. So we'll just run that search, and then now we can see we've got 164 files in there. So hopefully we've got some in here, right? So we've got Mika here, and maybe she's crying tears of joy because she saw something really nice, which hopefully happens to at least everybody at least once in their life, right? And then let's say we've got all these files in here. Another option we could choose is intersect, right? So this will tell us that every query we run in here, any results returned by this query are then going to be intersected with the files in this query. And the important thing to know is that this selection is always the main set. So any intersections are done against this set and not against this query set, right? So if I want to query, now I have any file that have Rika and Mika in them. Say I want to specify all of those files, but they have to have either one of them smiling, right? So we'll do a search of smile, and then any file that's returned in this search is then going to be intersected with this section, and then hopefully what we should see is only files that have either Rika or Mika smiling in them, right? So we should see probably that this file doesn't change because they're smiling in this one right now. So we do that. We see we went from 160 something files to 128. This file didn't change because it's tagged with smile for both of them, right? Which is nice. They're smiling in that one. She's smiling in that one. Smiles all around, which is just perfect, right? So say now what we want to do, now that we've got our intersection, we realize that we don't actually really care about seeing, maybe we don't care about seeing pictures that have, I don't know, Kirari in them. That's really kind of cruel to say that about her because she's so nice. But say that we just don't want to see her in any of these results. We'll run a difference, right? So we can do that, and we'll just difference her against all of these. And since we didn't want to see pictures with her in them, when our new result set was returned that was differenced, it just went to the next file because we wanted to get rid of that one, right? So that's something that Tagger does automatically for you. Maybe it's kind of helpful. Maybe it's not. I don't know. But none of these should have Kirari in them unless I mistagged them, right? Doesn't look like any of them do. So that's how those set operations work. So as you can see, we've covered how to do kind of just basic, like, tag, subtag queries. We've covered how to do individual queries, combined with what we currently have in the selection. Now what we want to talk about is how to do multiple of those operations in a single query. So everything that we just did just now can all be combined in a single query, which I think is very cool personally. So I'll talk about that now. So let's see, what did we start with? We started with Rika, didn't we? So we want to find, oops, let me spell that right. Every file with Jogasaki Rika attached to it. We want to union that, and I'll talk about this after I've written everything out. And we have our parentheses here. Everything that has Mika in it, we want to intersect that with everything that has a smile in it. And then we want to difference that with Kurari, who, once again, is kind of mean to do that too. This should return the exact same result set that we had in the previous one. So, you know, if it doesn't, I'm going to be kind of embarrassed, but alright. It kind of looks to me like it did, so that's really cool, right? We can see at least that this image is still in there. They're not in the same order, you know, which I would expect, but we do see some of these same images, which is good. This one maybe is a little bit misleading until you realize that, oh, actually, she shouldn't be in here, so, you know, maybe that's a mistake. It shouldn't be in here, so that's a bug. I might have to think about that, to be quite honest. So, you know, maybe slightly embarrassed. But Rika's in here, and she's smiling, which at least is good. Oh, actually, you know what? Now that I think about it, that actually does make sense that that does appear. Okay, so we'll talk about that. So, the way that this query is grouped, we will talk about these little tokens right here which appear. These are, you know, maybe as you've guessed, are set operation tokens. So, just like we have an implicit R dot before all of these, we could, you know, have a D dot, we'd have a P dot, that won't return anything. But these are set operation tokens. So our set operation tokens are either this U pipe for union, or an I pipe for an intersection, or a D pipe for a difference. And so those separate your queries like this, right? And so what this is telling it to do is that we want to find every Rika unioned with the results of anything contained in this query. So that's probably why Kurari is appearing in this. Maybe if we didn't want it to, it's because we didn't actually formulate our query correctly, right? And so here what we can do is we can think about this query as its own query, because it is its own query, right? So what this query is saying is find every Mika that's intersected with anything in this query. So what this query is saying is find every smile that's differenced with every Kurari. So, that shouldn't really be happening either, to be honest, because this image has a smile in it, but it also has a Kurari in it, so it shouldn't really be showing up. I'll have to think about exactly why that's happening. But, you know, post bug fixes, post investigation, that's exactly what this query should be doing, right? So you can think about it pretty logically and just say that all of these parentheses, in each parenthesis is a separate query, and then each of these queries will return a set of files that is then combined with the other queries however you specify it to be, right? So if you have a set operator, you probably have to have a parenthesized query in it. I think the QL might throw an error if you don't have a parentheses after that. Maybe it won't. I don't quite remember, and I've had a little bit to drink, to be quite honest with you. But this is pretty much how these go. So here, what we'll do is we'll try writing the same query. Let me run this again. So that file appears in there. Yeah, I don't know. That shouldn't be happening, but we'll have this same query in here in a different way, right? So this should return the same set of files if I do it this way. is we will have, and also, by the way, an important thing to know is that if you want to have parentheses as your first term, you need to have a set operator before it. The set operator is ignored completely, so it doesn't matter what it is, but you need to have one before it. That's also kind of another quirk with your query language. But say we want to find every Rika and every Mika, right? And so you notice that we didn't need to have parentheses before this one because it's just a single subtag, so it's obvious how it wants to be combined, right? So it doesn't matter. And then we want to intersect that with here, and actually maybe what it might be better to do is if we put this all, oops, doesn't work like that. It's not an IDE, so you can't just select stuff and then wrap it in parentheses. But I think what we'll actually do, we'll have this query here. We'll go ahead and define our last term, right? So we don't want to see Kurari in any of these, so we'll just go ahead and put her last because we know for sure we don't want to see any of her in there. Then we've got this one, which is going to have our Rika and Mika, like so. And then we want to intersect that with anything that has a smile. So this is first going to find the union of anything that has these tags, and then it's going to intersect them with the smiles, and then it's going to difference them by Kurari, which, you know, probably is not going to happen now that I see it, but... Oh, hey, well, that one worked better, so that's cool. Hey, you know what? Maybe I was right before in that we didn't write the query correctly in the first place. Here we can go ahead, we can search through these tags here, and we can just see if there's any characters that we don't want to see in here, right? Kurari's not in here, so that worked. So I was right before. We wrote the query incorrectly, and then here is the actual improved version of it, right? So, just goes to show you I don't actually understand what I've written in code all that well until I mess with it, but here it is. So, I apologize for the meandering as it is, but you know, maybe this kind of gives you a starting point on how to formulate some queries. I know it's really kind of weird and maybe kind of unintuitive. Yeah, but that's you know, pretty much how an advanced Tigrid query might work. One thing also that I want to touch on real quick before I end this is that we see here that each of these queries really only has one term in it. So what happens if you write multiple terms without specifying how you want to combine them, right? So, you know, we'll just say that we just want to do J Rika, J Mika, smile, and Kirari like that. So what happens if you do this? So we know from the first part is that all of these have an implicit R dot, right? Oops. Oh man, I just messed up. R dot, J, Rika, they all have an implicit R dot. R dot, smile, R dot. You'd already like that, right? But they don't have any set operations telling us how we want to combine the files that are returned from any one of these, right? So by default, the same way that Tagger assumes that any pattern that doesn't have a query criteria token in front of it, Tagger will assume that what you actually want to do is find the intersection of all of these tags. So what we're telling Tagger to do is find any image that has both Rika, Mika, a smile, and Kirari on it, right? So that's an implicit and so these are the only files that I have that match these. So that's an implicit intersection, and it's important to understand that that's how Tagger works. It combines things with an implicit and not an or, right? Which is important to understand. And let me think here. Maybe something else that I can touch on also while we're doing this is that it works the same way in subtags. So let's say I want to find any Yui pick, and I'm going to use Yui as an example because I've tagged her most extensively probably. So I'll say I want to find any Yui pick that has a subtag with portrait with any infra descriptor to portrait and any infra descriptor to smile. And so what it'll do is it'll find first any file that is subtagged with any file that is tagged with UE that has a subtag of portrait, and then it'll intersect that with any file that is tagged with UE that is subtagged with smile. So it's actually running for both of these terms, excuse me, it's running two different queries and then intersecting the results, right? So there we get to see, you know, maybe kind of one of my saucy UE bikini pictures. But that is what it's doing, right? So we can see this has both portrait and smile subtagged to UE. This has both 2/3, which is an infra descriptor to portrait, and smile subtagged to UE. Here's another saucy pic. You know, I don't know. Maybe it's kind of embarrassing to show those. I could talk for a little bit on my opinion about that sort of thing, but that's not for the tutorial pictures to show. But lest I look like a hypocrite, I don't want to be like that. Yeah, but in the same way, we have here this portrait, and then here this, you know, the good old :D, which is a infra descriptor to smile. So that's important to note. How those queries work, right? So those are ands, but they operate on subtag ands, right? So I apologize for the long video, a little bit rambling. Querying with the tagger QL is very useful. You can do some pretty advanced queries with it, as we've seen. It's quite easy to formulate queries incorrectly. So it maybe takes a little bit of thought to how you want to formulate them, but it's a very powerful tool to do some pretty complex queries at a single step, which I think is quite useful. So thanks for watching. If you've got any more questions, you probably know where to find me. So yeah, thank you.